afternoon, everyone. Myself Ganesh Chilen from Pune, Maharashtra. Today we are going with battery pack design, webinar on battery pack design. Today's agenda for that today's webinar is comprising with following points. First is basics of battery, then the various components of battery, battery battery pack design, the various aspects of battery pack design, such as electrical design, mechanical design, thermal design of battery pack, then battery management system and safety, and followed by the question and answering sessions. Basics of battery pack. Battery means we use the battery for the energy storage device. Means suppose we require some energy from one form to another form. Means chemical energy is converted into the electrical energy with the help of battery. So we briefly review of some of the energy storage device and their benefits and their challenges, and there are the many different types of chemistries and form factors of batteries. Firstly, we go with the chemistries of battery. There are various chemistry batteries: lead acid batteries, nickel metal hydride batteries, nickel metal chlorides, sodium sulfur batteries, sodium chloride batteries. There are all the types of batteries. There are two main categories of batteries. Means firstly primary batteries and secondary batteries. Primary battery basically the batteries which we cannot use again, and the secondary batteries that the rechargeable batteries. Means that batteries we can charge, discharge, and use for the multiple times. In secondary batteries, basically now we use the lithium-ion batteries, and then we've seeing the various components of battery. There are mainly 5 components of batteries. Means the majorly we focus on the main 5 components. First is the cathode. The cathode is the positive electrode of battery cell, which we for the synthesis of cathode we use the many chemistries such as LFP, NMC, LTO. All the chemistries we use for the cathode. From that cathode active elements, we classify the batteries. Currently, we classify the batteries only with respect to their cathode materials, such as NMC batteries, LTO batteries, LFP batteries. All the cathode electrodes. From that chemistry, we define the batteries. And second most important component in battery is Sagar, your any questions? Lastly, we have the question and answering session. In that, you post your questions. Hello, Naveen. Hello. May I audible to everyone? Please give a thumbs up because I didn't see.
Yeah, you are audible, Mr. You can go ahead.
Okay. The next important component is anode. Anode is the negative electrode of battery. There are now currently the various fields are open for the research in anode and cathode, such as currently we use the NMC 811. There are many methods for cathode. There are many research scope in that field, such as the synthesis. There are synthesis methods. We can change the synthesis method. Along the synthesis method, we develop any another material to replace the cathode materials, such as in previously we used the NMC 532, NMC 11, NMC 33. For that replacement of that chemistry, that there is a very strong research area in that material synthesis. And then the procedure of making the cathode active material, in that firstly we synthesize that cathode active material, and then that powders we are coating on mostly on aluminum foil. In some case we use in aluminum foil also for, and that cathode active material we use the battery, and we optimize the synthesis process. That synthesis process, when we optimize that synthesis process, then all the automatically the cost of battery get reduced. Then second component is anode, and another important component is the separator. Separator, we use the separator in between the anode and cathode to prevent the short circuit of any batteries. In that we use the electrolyte for the smooth conduction of ions from anode to cathode. When we use the when we apply the energy, means when we charging the that's in that time the elements from cathode ions travels from cathode to anode, and while the we
Excuse me, sir.
Yes.
It's okay, sir. Now only I joined the meeting. Sorry for delay.
Okay. Hello.
Hello.
Yeah.
Sorry for delay, sir. Now only I joined the meeting.
Okay, no problem.
Thank you.
No. The electrolyte is the conducting material from the transfer of ions from anode to cathode, cathode to anode, while charging and discharging. And another important component in battery is the enclosure. We have various form factors in batteries, such as cylindrical cell, pouch cell, and prismatic cell. While that design that cell, we require the enclosure. While selecting that enclosure, we use the suitable material for that, because once you choose the material, while in battery pack, that material get increase the weight of battery pack. That's in battery pack, we have the first aim is to minimize the weight of battery. That's the most difficult challenge in the design of battery pack. And then the fifth material is the hello.
Yes, Ganesh.
Yeah. May I audible?
You are audible.
Because
Yes,
I'm
you are
in
audible.
the Okay.
Please continue. Okay.
Yes. Then we go for the battery pack design. While designing any battery pack, we are required the 4 major perspectives. First is the electrical design, in mechanical design, and thermal design, and battery management design. While designing the battery pack, there are various fundamentals are very important for designing the battery packs. Means while designing the electrical system, we require the robust electrical system, because while the battery pack operate in various conditions, while acceleration and immediate acceleration, immediate disacceleration, all that the condition we have to consider while selecting the battery pack. And then mechanical robustness means while designing the battery pack, we require that robust mechanical design, because in every condition, your battery pack get the various vibrations from the other systems present in vehicle. In that time, your battery pack should be the having that robustness in that, because we have very different road conditions. In that time, that system with works without fail. That's why we require that the strong mechanical design for the battery pack. Then thermal stability. Thermal stability is the very important factor while designing the battery pack, because in India we have the various temperature difference. Means we go for the go in north, there is temperature is very low. While traveling to the south, we have the highest temperature in. We have to design the battery pack to satisfy all the temperature conditions, because the lithium ion battery, suppose we consider the lithium ion battery. In that lithium ion battery have the specified temperature range, means from the ambient temperature range is the 20 to 35. In some condition we use still 45. While considering all the temperature conditions, all the design, we have to design the electrical system for the battery pack. And mainly the last one is the battery management system. Battery management system is the brain of any battery pack. Suppose we require that battery pack for a particular application. Suppose we use that battery pack in four-wheeler application. In that we require the certain data, means how much the charging is remained, how the temperature are rising at a different temperature condition, what are the current we get from the battery pack, what are the is any hotspot region is generated in the cells, what are the state of health of every cell. That things are known from the battery from battery management unit. And while considering the while designing any battery pack, we require all that four system in four important things for the design of battery pack. There are various stages of battery pack design. First is cell configuration. In cell configuration, we use the NPNS theory. Means NPNS theory means some cells we use in series, some cell in use in parallel, according to the application. Suppose we require the high voltage. In that condition, we use the cells in series combination. And in suppose we require the high capacity. In that time, you use the in parallel structure. That's why we use that MPNS theory to fulfill our requirement. Then the structure. While designing the battery pack, we require the robust structure. Means we require the case, cover, the end plates, tie rods, and cell holder. That material we require the lightweight material. Especially design of the cell holder, we require the that material is very lightweight, because once the weight of battery pack is get high, means the battery pack will get increased. In that time, we reduce our capacity. While designing any uh, vehicle battery pack, in that time we require that weight consideration is the most important. That while selecting the materials, we require that uh, uh, consideration for the minimize the how we minimize the weight of battery pack. Then that's the electrical perspective. From that's the mechanical perspective. Sorry. While electrical perspective, we require the bus bar, wiring harness, and fuses and plugs. While designing the bus bar is the very important for uh, connecting the two cells and connecting all the cells that we require the bus bar. Suppose uh, we design the bus bar for battery pack. In that, we have to check the its resistance and the temperature and current flowing from that bus bar. That three are the major major parameters to check in that while designing the bus bar. And then cooling systems. Cooling system in high temperature region, we require the cooling system for the battery pack. Either we use active cooling or passive cooling. We see that cooling system in thermal air, and the most important thing is the safety. Means every battery pack will be safe from short circuit and overcharging and discharging. For that safety, we use the BMS system, and also control. For control, we also use the BMS system. From BMS, we get the data. We get the various data from BMS. From that, we analysis that data, and from that data, we predict the state of charge, state of health of battery, and how much DOD in that battery pack cells. With and cell balancing also we can done from the BMS. Then there are the major components in battery pack. First is the battery cells. Mostly we use the cylindrical cells for battery pack. In that we use 18650 that battery cell, and then compression pad and insulation pad. Compression pads and insulation pad are the in between the two cells for avoiding that compression between the two cells. While when we charge, that's the volume of battery slightly gets increased. For that, we require that compression pads and insulation pad. Then plastic cell holders, bus bar and bus bar holders, end plate, base plates, thermistor and voltage sensor for sensing the various information from the battery pack, temperature, voltage and currents, wire harness and BMS. Firstly, we are starting from the electrical design of battery pack. We have the three form factors: prismatic cell, cylindrical cell, and pouch cell. So from one cell, we can make the module and module to pack. When we require the high voltage, in that time we use that cell in the series, and while when we require the high capacity, that time we use that cell in parallel. According to the application, firstly we get that number, how much number of cells we require for the achieving that particular voltage and particular capacity. From that calculation, we can calculate the number of cells, and then we proceed for uh, the design of bus bar and next process. Uh, there are first we go on with the bus bar design. Why bus bar is more important? Bus bar design is more important because for if the bus bar is can improperly designed, in that time we facing a lot of challenges. First is the system operation means when we design the bus bar wrongly, in that time uh, we face many problems such as we get the less current, and when we get less current in that time, definitely we lose our efficiency. And when the resistance is increased in that bus bar, and that time the joule heating, and that the temperature of that bus bar is get high, and that if the temperature get high, in that time that bus bar material get melt, and while melting that molten metal is spread on the cell. In that time the cell also get damaged, and the other, if that molten material spread on the other wire, and that system also get damaged. That's why while designing the bus bar we have to take care for various parameters such as temperature, resistance, and how much current we can transfer from that particular system. Then second is the and for a bus bar we have to choose the conductor material for the bus bar. Uh, Ideally, we use the copper and ideally we use the copper, and copper is used for the copper and nickel used for the design of bus bar. Sir, we share the PPT after the session. I'll share with Naveen sir. They will share to you. Uh, Firstly, we go on with the selection of bus bar material. Bus bar material selection for the material which we have the low electrical and the material which have the low electrical and thermal resistance. That suppose the material which having the low electrical resistance, in that time the heat generation in particular that bus bar is less, and while the temperature is not rise in that condition, and the thermal resistance, and that high mechanical that requires the high mechanical strength and tension in compression and shears, and when that material having the resistance, in that time the temperature is raised. In that time we require that there is a chances for the fatigue failure. For that, we require the high resistance to the fatigue failure, and the most important is that material is very. We require that material for easy to fabrication. That's why that all the important things. That all the important things which required for designing the bus bar. And another is major concern while designing the bus bar, that's the joining method. The joining method means while we use that either a mechanical joint or the welding joint. In that time we require mainly focus on that contact point. Means suppose we use the mechanical joints such as we use the bolt joint. In that time, we get the that minimum contact support, minimum contact point. From that, contact resistance become less in that scenario. But when we join with the welding joint, when we join with welding joint, in that time we mainly focus on the point of contact. We require the single point contact. In that time, now when we get the single contact, in that time the resistance of that bus bar get reduced. We have one case study on design of bus bar. I'll share the that case study while sharing the PPT. I have not put in that in the PPT. That I'll share that bus. Ravindra, we have taken that all questions at the end of session. Next is the mechanical design of bus bar. While designing the mechanical system for the bus bar for battery pack, we require the material selection. Mainly, we recommend the lightweight materials such as the aluminum casing for the battery pack and safe structure. Firstly, safe structure means battery pack operate in various conditions, various temperature conditions, various road conditions, and various vibrations are embedded on that battery pack. For that, we require that safe structure for the battery pack. That we require the cost. Also, one thing kept in mind that the cost of battery pack. While we use that while selecting the material, we mostly use the lightweight material and for the reduce the weight of battery pack. Mostly we use the aluminum, but now the research are going on the use of composite material for the battery pack design. There are various tools for design of battery pack. On SolidWorks, we can create a 2D, 3D models of a battery pack and CATIA and any another CAD tool such as Fusion 360. Creo. On that, we can use create the battery pack 3D model. Then the thermal design of battery pack. Why we need the thermal design of battery pack? Because thermal design of battery pack, suppose we have that one battery pack with having 50%, the battery pack which operate on 50 degrees Celsius at 800 cycles, and that the capacity goes at the 40% of total capacity. Use the 40% of their total capacity means initially the charging is 100% and then reduce at the 40% total capacity of battery pack. When suppose that battery pack is operated on 50 degrees Celsius for 800 cycle. And same battery pack we operate on the 55 degrees Celsius. Its cycles life get decreases. We get that 550 cycles, and the capacity is 30%. Means that suppose the increase in temperature of increase in the temperature, in that time the automatically the capacity of battery pack get capacity and cycle life of battery pack get down. For that we maintain the temperature ambient temperature for the battery operation. Also the temperature effects on the efficiency of pack, because as the temperature increase, the internal resistance also increase. That's in that time internal resistance also increase. And that time the ions are not easily move from anode to cathode and cathode to anode. In that time we reduce our efficiency also. Then charge acceptance means the temperature rise which follows the thermal attacks. Thermal resistance also increase, and that high current discharge and low heat because of the local because in battery pack we use this in cell we use that separator. Because of localized heating, there is a generation of hotspot. High temperature regions are found in the cell. In that time that separator gate melts, and if the separator gets melt, the short circuit and the safety issue arises in that time, in that scenario. That's why we require the optimum temperature. Also we facing the problems on powers and energy availability and safety and reliability and life cycle and cost of the battery pack. Then we go with what are the requirements of required function for thermal design. So while designing the thermal system, we firstly consider that the compactness, means that battery thermal system will be the compact. Suppose we taking that battery pack, in that we use that cooling system just below that battery pack. One is below from battery pack, and from top side that we use that cooling system, that cooling pads. From that we we employ some cooling elements such as refrigerant, any coolant, or we use the natural cooling also for that. And another next one is the lightweight, and that battery thermal system is easily packageable and that reliable, and cooling system that easily gets serviceable. That time that all the considerations are useful while designing the battery pack. And another most important consideration for battery pack is the temperature consideration, because suppose we consider in the India, from the Indian only. Suppose we travel to north, in that the temperature ranges is very low. That means with in Leh Ladakh we experience the minus temperature. Suppose we travel to the south, we definitely get the temperature above the 45 till 50 degree. In that time we have to use the battery pack on such a condition, while considering that all the conditions, all the chemistries, all the parameters, we take the temperature consideration. Ideally the battery pack is of lithium ion cell with NMC chemistry is operated on 15 to 35 degrees Celsius is the ambient temperature. Then heat generation in battery pack. Which are the parameters are responsible for the heat generation in battery pack? Which they can calculate from the Joule heating. From Joule heating model, we can calculate the heat generation in particular battery pack by I square R by using the formula heat generation in watt is equal to the current I square into R, means the current in particular cells and the internal resistance of that cell. That the From that we can calculate the Joule heating. And there are several regions in the battery pack. In that, they are responsible for the heat generation. There are mainly the cells that suppose we consider the lithium ion cell. In cell, while the electrochemical reactions, that energy get in the internal temperature is get increased in bus bar. While we see that design of bus bar, in that the temperature is the most important criteria for design the bus bar. Now, suppose the internal resistance in the bus bar is increased, then that time the temperature is increased. That's the temperature that heat generation in bus bar it leads to the failure of whole battery pack. In BMS also the increase the temperature. To overcome that temperature problem, we have to use that some cooling systems. There are two modes of thermal management system. One is active cooling and one is the passive cooling. Passive cooling. In active cooling, we use that active cooling. We require the air, liquid, refrigerant, and any hybrid cooling we use. In that, we require external force for that active cooling. For passive, we simply use the PCM material or any natural convection. We can. Hello. Hello.
Yes, Ganesh.
Sir, may I audible to?
Yes, yes, you are audible.
Yes, you are audible.
Okay, okay.
Please continue.
Yes. We use active and passive cooling system for the battery cooling purpose. And there are various according to the application, we can suggest that cooling systems means which kind of cooling system is suitable for the which kind of cooling system we required according to application. Suppose we required the high current, high temperature region. In that time we use that active cooling. But suppose we require that the normal functioning, the temperature rise is not very high. In that time you can use that normal passive cooling. We have case studies on directional thermal properties for simulations. We can simulate the thermal management, means on in ANSYS we can simulate the how the temperature rise. Means we propose given the particular conditions, and from that condition we find the temperature rise in particular.
Sir,
We can find. Hello.
how much temperature rise in battery package during thermal?
Means, pardon, sir? Can you please?
Told 30 to 60 degree only.
The ambient temperature, we have that ambient temperature condition is 15 to 35. Suppose according to your application, you require the high current, high voltage. In that time, ultimately the temperature in the cell may get increased. In that time, by joule heating, we can calculate the temperature. And for that, also we can calculate from the simulation softwares on ANSYS and console. We can define the how much the temperature is rise. The maximum temperature it means we given that condition. Suppose from 100 to 100 degree SOC to 20 degree. 20% of SUC at a particular temperature, and particular temperature. From that, we can simulate the how the highest temperature we will get in that particular application. We can calculate from the simulation. For that, we can use ANSYS Workbench and ANSYS Fluent. And another one software which is console multiphysics. In that electrochemical model, we can use we can check the temperature rise and cooling system. And another one is when we use particular cooling system. In that, suppose we use that, of course, passive cooling, active cooling system. In that, we require the any compressor or any external energy source for the run that cooling system. But when we use that external cooling system, that we require the require the power. That power we can draw from the battery pack, and ultimately your capacity and your range of vehicle get decreased. For that we use that another cooling system is the passive cooling system. In that we you cool your system by naturally or any PCM material. According to the application, how much the PCM material we use for that particular application, we can calculate from software also, or we can manually also calculate the how much PCM material, phase transformation, phase change material we can use for that particular application. And the last one is the battery management system. Why we need the battery management system? Because we require the battery management system is the brain of your battery pack. While functioning the battery pack, smooth functioning of battery pack, that we require that for smooth working of battery pack, we require the fully efficient BMS system. From BMS, we can get the data like current, voltage, capacity. All the data we can calculate from the get from the BMS. In BMS architecture, there are many types of BMS architecture. In that, slave BMS and master BMS are the two types. In that, from that two types, we can design the battery management system and battery control system for that. Another one is BMS topology is the centralized BMS and distributed BMS. For that, in a centralized BMS, all the cell modules are connected to the one central module. And in distributed BMS, we can distributed BMS means the slave BMS. In that, we connect BMS for all the battery models. In BMS hardware, there is including the CAN, LAN, communication components, capacitor, registers, and various sensors, temperature sensor, current sensors are connected in the BMS. And another one important function of battery management is the balancing of cells. Means we have to balance all the cells. All the cells, because the effect of imbalance cells, suppose when any cell is get low capacity or low SOC, that impact on all whole battery pack that required. We have to require the cell balancing for every battery pack. And there are various safety standards for the battery pack. Safety functioning of battery pack, we have many standards for the battery pack, such as the international standard specific for the safety required is IEC 62133. That's the standard for battery safety. And another various SA standards for the battery safety. IEEE standard for the battery sizing, and the International Electrochemical Commission. In that, IEC 60050, IEC 61427, IEC 61429. That all the standards for battery safety. And Institute of Electrical and Electronics Engineering also have the standards. And also the Chinese standards and industry organizations, that UNS standards for the battery safety. And European standards. There are several standards in Chinese EV standard. QCT 743 is the 2006 standard for lithium-ion storage of battery for electric automotive safety. That's all the standards for the safety of battery pack. Okay, Naveen, that's from my end. If any questions, you can unmute yourself or paste in the chat box. Hello? Hello?
Hello.
Yeah, hello?
Yes, Ganesh.
Yeah, is any questions? Please unmute yourself and otherwise put in the chat box.
If anyone having question, please ask.
Oh, sir.
I have a question. Thank you for the presentation, Ganesh. It was really
Ma'am, your voice is so low. Can you hear?
1 minute, 1 minute. Let me increase the volume. 1 second. Am I audible now?
Yeah, yeah.
Thank you for the presentation. It is very much informative. I have a small basic question. What is the battery capacity and how will it differ for two-wheeler and four-wheeler? Can you please elaborate?
Ma'am, according to the application, so for a two-wheeler, we require the 4 kilowatt battery pack, and while in the two-wheeler, 4 kilowatt is sufficient for 100-kilometer range, and in four-wheeler, maximum we require 30 to in between 30 to 40 kilowatts of battery capacity of battery pack.
Okay, thank you.
Ganesh, please check the chat box.
Okay, just a minute.
Hello.
Yes, sir.
I have one question.
Okay.
So, is regarding battery design,
Okay.
is battery charger is also included?
No, sir. In battery pack design, we didn't design the charger. For charger grade, we have to connect with from battery pack. We use that electrical control system. From that control system, we charge that battery pack. We connect one grid on that. From that grid, we can charge. In battery pack, we didn't design the charger.
Okay. Thank you.
In battery pack.
Thank you.
Hello, sir. Good evening. I have a question.
Yes, sir.
Yeah, actually, you have mentioned some safety standards. Can you display it or can you share that presentation so that we can have a good...
I'll share that standards to the Naveen sir. With all that standard I mentioned in the PPT. Some of that I have that soft copies also. I'll share with Naveen sir.
Sure. And regarding any software is there to design battery design?
Sir, for battery pack, mostly we use that SolidWorks and CATIA. And also one is the Fusion 360 also the good software, but mostly in SolidWorks, most of the companies are prefer the SolidWorks for the battery pack.
Okay, thank you.
Thank you.
Sir, I have a question, sir.
Yes, go ahead.
Sir, how do you do the thermal management, sir? Is there a software for that as well?
Yes. We do this thermal simulation on a battery pack on ANSYS. ANSYS also, and another software is COMSOL. COMSOL Multiphysics is that software. On that we can analysis. We do the thermal analysis, and in ANSYS Fluent we can analysis the CFD analysis of battery pack with cooling with using cooling systems.
Okay, sir. So this ANSYS is Simulink, right?
No. That Simulink is MATLAB Simulink. That's a different software. We can use that MATLAB Simulink for the battery management.
Okay, sir. Yes, sir. Understood. Thank you.
Hi, Ganesh sir. Sorry, Gaurav this.
Prabhat, you can contact with organizing Naveen set for the certifications.
Hello, Ganesh.
Yes.
I have one question. I am into the BIW robotics simulation.
Okay.
So I am looking forward for the opportunities. And could this battery pack management should will help me in the future to for as an add-on to my resume?
Yes, definitely.
Okay.
You are in robotics. You are in robotics now.
Yeah. Actually, because nowadays EV electric vehicles are being made for most of the industries. So, is this useful for me in future if I may I get into it?
Yes, definitely. You can go through the battery management system in that the MATLAB and simulations is related to the your current area. Means you are doing the robotic simulations, no?
So my job is to build a line on which all the child parts get completed to the parent sheet, which is gone to for the body shape.
Okay, for that control system and battery management in that you go with MATLAB and simulations.
Okay.
That's a very important area of battery
Thank you, Ganesh.
management.
Thanks a lot.
Yeah.
Hi, Ganesh. Can you hear me?
Hi.
Actually, I have joined late because I had some work. Actually, currently I'm working on EV fast charging infrastructure. So we are going to use LiFo4 battery pack. So for our to charge a two-wheeler, okay, for 48 volt or either 48 or 72 volt. And we are going for the hardware also. Means we are going to make the hardware.
Okay.
So my question is, can we make the simulation in COMSOL, the entire thing along with the converter in COMSOL or any other simulation platform?
For that, we can simulate in Simulink, and another one is software for that charging infrastructure.
Which one?
I will connect with you, Gaurav.
Yeah, can you share your number or something so that I can connect?
Okay, I'll share my number in chat box.
Okay, please do share. Yeah, thank you.
Yeah.
Hello.
Hello.
Yeah. I have a doubt.
Yes.
Yeah, for cylindrical cells, which is better, like laser welding or wire bonding?
For cylindrical cell now, laser welding is good for that.
Why so?
Because from laser welding we get that point contact. From that point contact, we can get the minimum resistance. That's why we use that laser welding. But when we require that application with another applications, we can use also the another mechanical joints also for that.
But can't we get wire point of contact in wire bonding?
Yeah, in that condition, we also get that point contact, but the temperature condition and internal resistance are the two parameters for that joining condition.
Okay. One more question. For four-wheelers, which will be the good cell composition?
Means?
Like LFP or LMC? NCA?
Currently, NMC is good, but in NMC we didn't get that much of cycle life as compared to the LFP. So NMC, LFP, because Tesla is using LFP, they get that high range and high cycles also. That's LFP is important.
Why?
Pardon?
Okay, yeah. Okay, thank you.
Okay. Okay, Naveen sir, can we stop or? Hello?
Okay, hello everyone. This side Kashish from ISIEINDIA. Hope you like the webinar and looking forward to enhance your skills in this same domain. Okay. So here I would like to introduce ISIEINDIA products which will help you enhance your skills. Kindly watch a small video about ISIEINDIA courses. Thank you.
Hello, ma'am.
Your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISIEINDIA has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, global wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD, and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation and product design and development. It is a combination of 6 labs including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab and renewable energy lab. Each lab is consists of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, 2-wheeler, 3-wheeler, 4-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Thanks everyone for watching this video. Hope you guys have understood the products. So any of you wants to enroll in this course or interested in the course, kindly send us the inquiry through a QR code displayed on your screen. If you have any questions, you can ask here as well. Thank you.
Yes, ma'am.
Share your number.
Hello. 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 Am I audible?
From where we have to download the certificate?
Hi, how to download this certificate of this webinar?
For downloading the certificate, we will share on your mail. Okay. Please check your mail once. Anyone wants to join our course, please scan this QR and fill the form. Okay.
Sir, I haven't got any of the mails actually.